In the previous unit, we learned how Matlab passes arguments in function calls. Let's now look at 3 cases to make sure we have a complete understanding of what's happening. We'll do this for the simple vecop function with slight modifications to it and track through the base workspace and the subsequent function instance workspace, which is created when the function is called, and then what happens as the function exits and control returns to the base workspace. Let's create 2 vectors named v and w in the base workspace, and then call the function vecop. In this example, the input variable names inside vecop happen to be the same as the names of the variables back in the calling workspace. But remember that these variables are passed by copy. So this v is a copy of that v, and this w is a copy of that w. We know it's really a delayed copy, but for the purposes of understanding function calls, think of it just as a separate copy. Now the code proceeds as it did before, forming the dot product and the cross product. Here's an extra line. V is overwritten and set to the scalar 0. In the function instance workspace, it changes to a 1 by 1, and now the function exits, returning control to the base workspace. When we do that, what is the value of v back here? Well, it still is the vector 1, negative 2, 3. So the message is that input arguments are passed by copy. So changing their values inside a function does not affect the value back in the calling workspace, regardless of the names. Here's another example to drive home the point that variables in a function are local to the function. Again, create vectors v1 and v2 in the base workspace and make the call to vecop. The input arguments are passed by copy, so v is a copy of v1 and w is a copy of v2. Do the dot product and cross product calculation, creating new variables in the function instance workspace, and then define a new variable temp in the function instance workspace, the scalar 0. The function exits, returning control to the command window. The output arguments are passed back, creating variables a and b in the base workspace. And of course, the variable temp is undefined. Variables defined within a function exist only in the function workspace. Only output argument variables are returned to the caller's workspace. Finally, let's look at one more example. The same familiar vectors and a call to vecop. Input arguments are passed by copy. The familiar dot product and cross product calculations occur. And then a piece of code which tries to access the input argument, but not the passed in value of the input argument, but the original copy back in the caller's workspace. That creates an error inside vecop m at line 7, saying that v1 is an undefined variable. So even though v is a copy of v1, v1 itself is not visible in this workspace. The message? Copies of caller's input argument values are in the function workspace. Other variables defined outside the function workspace, here v1 for instance, cannot be accessed inside the function. All right, that completes our initial introductory study into functions, and specifically functions in the Matlab environment. Good luck on the homework problems.